Okay, so let's have this topic, solving for integral using transformation by trigonometric formulas. So for integral of tangent to the power m, secant to the power n, the given should satisfy one of these two conditions. These are the two conditions. M, or exponent of tangent, should be an odd number. Then n, or exponent of secant, should be an even number. So we have this given, so the integral of tangent to the power 4x, then secant to the power 6x dx. Now, since this given satisfy one of the two conditions, that the exponent of secant is even number, so therefore we need to work on secant, and we need to have this secant squared u. So to have secant squared u from secant to the power 6, so this becomes secant to the power 4, then secant squared x dx. Then continue working on secant, since there is an identity that secant squared u is equal to tangent squared u plus 1. But first, we need to rewrite this secant to the power 4 to secant squared. So this one is equal to secant squared x to the power 2. Then bring down the secant squared x dx. Then using this identity, so substitute this tangent squared u plus 1 to this secant squared x. So we have now tangent to the power 4x times tangent squared x plus 1 to the power 2. Then bring down the secant squared x dx. Then expand this equation, so using this SMS method, so we have now the integral of tangent to the power 4x, then s, the square of the first term, so the square of tangent squared x, that's tangent to the power 4. Then m is 1 is multiplication, so multiply 2 times 1, that's 2, times tangent squared x, so that's 2 tangent squared x. Then s, the square of the second term, so the square of 1, that's 1. Then bring down the secant squared x dx. Then distribute this tangent to the power 4x. So we have now the integral of tangent to the power 8x plus 2 tangent to the power 6x plus tangent to the power 4x. Then bring down the secant squared x dx. Then from this given, so integrate every term and distribute the secant squared x to every term. So we have now the integral of tangent to the power 8x, then secant squared x dx plus 2. So you put this constant outside. Then the integral of tangent to the power 6x times this secant squared x dx. And for this term, so the integral of tangent to the power 4x, then this secant squared x dx. Then using the U-substitution, so u is equal to tangent x, because the derivative of u, that's secant squared x dx. Then you substitute now your u and du. Since u is equal to tangent x, and we have this tangent to the power of 8x, so therefore we have now the integral of u to the power 8. Then this secant squared x dx is equal to du, so times du. Then plus 2 times the integral of u to the power 6 times du. Then plus the integral of u to the power 4 times du. Then using this formula, so the integral of u to the power n du is equals to u to the power n plus 1 over n plus 1. So this u to the power 8 plus 1, that's u to the power 9 over 9. Then plus 2, then this u to the power 6 becomes u to the power 7 over 7. Then plus u to the power 4 plus 1, that's u to the power 5 over 5, then plus c. Then simplify, so this u to the power 9 over 9, the same as 1 over 9. Then since u equal to tangent x, so we have now tangent to the power 9x, then plus 2 over 7. So the 7 put outside. Then again, u is equals to tangent x, so tangent to the power 7x, then plus 1 over 5. Then u equals to tangent x, so tangent to the power 5x plus c. So this is now the final answer. Then for this given, since this given satisfy one of the two conditions that the exponent of tangent is odd, so therefore work on tangent, and we need to have this second u tangent u. So we need to get one for tangent and get one for secant. So that tangent to the power 3 becomes tangent to the power 2x, and this secant to the power 5 becomes secant to the power 4x, then secant x tangent x. Then continue working on tangent. So since we have this identity that tangent squared u is equal to secant squared u minus 1, so this tangent squared x becomes secant squared x minus 1. Then bring down the secant to the power 4x and the secant x tangent x dx. Then integrate every term by distributing this to every term. So this secant squared times secant to the power 4 becomes secant to the power 6, then secant x tangent x dx. Then we also have this one, negative integral of secant to the power 4x, then secant x tangent x dx. Then using the U-substitution, so u equals secant x, then du, that's secant x tangent x dx. Then substitute now this u and du. So since u is equal to secant x, so therefore this secant to the power 6x becomes u to the power 6, and secant x tangent x dx, that's equal to du, so times du. Then minus the integral of u to the power 4, then secant x tangent x dx, that's du. Then using this formula, so plus 1 for the exponent, so therefore this u to the power 6 becomes u to the power 7 over 7. Then minus this u to the power 4 becomes u to the power 5 over 5, then plus c. Then simplify, so this u to the power 7 over 7, the same as 1 over 7, times u to the power 7, since u is equal to secant x. So therefore that becomes secant to the power 7x. Then we have this negative 1 over 5. Then since u to the power 5 and u is equal to secant x, so we have now secant to the power 5x. Then plus c. So this is now the final answer. Then for this given, so the integral of tangent to the power 5 3x times secant to the power 4 3x, since this given satisfies the two conditions that the exponent of tangent is odd and the exponent of secant is even, so in this case, I prefer to work on smaller exponent. Since secant is the smaller exponent, so I'm going to work on secant. But remember that for secant, we need to have secant squared u, and for tangent, we need to have secant x tangent x. Since I prepare to work on secant, so I need to have this secant squared u. So we have now tangent to the power 5 3x, then secant squared 3x, and this secant squared 3x dx. Then continue working on secant. So using these identities, so for secant squared u, that's tangent squared u plus 1. So this secant squared 3x becomes tangent squared 3x plus 1. Then bring down this secant squared 3x dx. Then simplify, so distribute this tangent to the power 5. That becomes tangent to the power 7 3x. Then this tangent times 1. So tangent to the power 5 3x. Then secant squared 3x dx. Then integrate every term. So this secant squared 3x dx distribute to every term. So we have now the integral of tangent to the power 7 3x times secant squared 3x dx. Then plus the integral of tangent to the power 5 3x then times secant squared 3x dx. Then using the U-substitution, so u is tangent 3x du. So since the derivative of tangent is secant squared 3x, but we also have derivative of 3x, that's 3. But in our equation, we only have this secant squared 3x dx. So divide both sides by 3. So du over 3 now is equal to secant squared 3x dx. Then substitute. So since u is equal to tangent 3x and we have this tangent to the power 7 3x, so that becomes integral of u to the power 7. Then this secant squared 3x dx is equal to du over 3. So times du over 3. Then plus the integral of u to the power 5 times du over 3. Then simplify, so we need to put this denominator outside. So we have 1/3 times the integral of u to the power 7 du. Then for this one, plus 1/3 times the integral of u to the power 5 du. Then using this formula, so plus 1 for the exponent. So now we have 1/3, then this u to the power 7, so plus 1, that's u to the power 8 over 8. Then plus 1/3, then this u to the power 5, so plus 1, that's u to the power 6 over 6, then plus c. Then simplify, so this 3 times 8, that's 1 over 24. Since u is equal to tangent 3x, so we have now tangent to the power 8, 3x, then plus this 3 times 6, that's 1 over 18, then u to the power 6, that's tangent to the power 6, 3x plus c. So this is now the final answer.